Hey guys, today we're going to be talking about 4.5, which is solving systems of linear equations by graphing. The TEK that we're focusing on is 8.9, which is identify and verify the values of x and y that simultaneously satisfy two linear equations that are in the form of y equals mx plus b from the intersections of the graphed equations. So for this lesson, the essential question is, how can you solve a system of equations by graphing? So we have to be able to identify and understand the words that are in this TEK and this question. So the first word we're going to look at is a system. And a system is a set of things working together. In this case, we're going to have linear equations working together. So that's going to be our system. So the definition of a system of equations is when we have at least two, so two or more linear equations on the same graph. So a system of equations is really just a system of linear equations, two or more equations on the same graph. Now, we have to be able to solve and identify what points they actually satisfy the two linear equations. So in this case, it's going to be called a solution. And what the solution is, it is a solution to the system of equations is an ordered pair. So it's going to be written in parentheses our x comma y. And both of these linear equations on the same graph are going to share that one point. Okay, if the ordered pair is a solution, that means that it satisfies both equations. So I can plug in the x and the y value for each equation that's graphed, and it will still come out to be a true statement. Okay, so let's take a look at some examples. A system of linear equations is when two lines work together or touch when graphed on the same coordinate plane. So, looking at just this first one, this is like when we have one linear equation. Okay, here's my coordinate grid, and here is my linear equation that we already graphed. If I put this one plus another one, for instance this one, which has a slope that you should already know is undefined, I'm going to put these two together. Okay, now to find the solution is when I put them together where it actually touches. So if I look at this third example, when I put them together it equals this one, which is my undefined slope, and this one, which is my positive slope because it goes up from left to right. At what point do they actually intersect? Okay, this point right here, there's no actual grid marks, but we know that intersects there. So there's one solution. This point is on both of the equations. So that's why it satisfies both equations, which means that that is a solution to the system of equations. Okay, so if they do touch, the points at which they touch are the solutions. So in instance, our solution should always be written as an ordered pair, which is just x comma y in parentheses. All of our solutions should be written in that way. Okay, so you should have already been able to fill this out, but the solution is when the intersection point of the systems is visible. So when there's an intersection between the two systems, wherever that point is, written it as a coordinate pair, okay, is going to be our intersection point or our solution. So here's a question for you higher level thinkers. If there's two lines are parallel, does it have a solution? Think about that for a second and see if you can answer that. If two lines are parallel, are linear lines, if they're parallel, do they have a solution? Okay, you should have visualized our graph, okay, with two lines, two parallel lines. We know parallel, they're never going to cross each other. They run side by side. They're equal distance between the two lines. So, are they ever going to intersect? Which means that's our solution, right? It's asking if it has a solution, and a solution is when they intersect. Does it? No. Okay, so when we have parallel lines, there's not going to be a solution. There's no solution because they never intersect. Okay, so we could have answers that have one solution, like this example right here. We could have some that have no solutions, like our parallel lines. And there's another type of solution. So if you look down here, I sort of want you to visualize this with your arms too. So if you look down here, we're looking at the different types of solutions. We already talked about the one solution in this system of equations. We talked about how there's no solution in this system of equations. And now we're going to talk about the other one. So, how many ways can you make a straight line with your arms? So right now I want you to hold up your arms and cross them. Okay, they cross at one point. This is similar to our system of equations. If I make, go ahead and draw your graphs for each one. We're going to do an example. If I just make two linear lines, there's my one line, just like my arms, and then it crosses over with my other arm, which is another linear line. Okay, I notice that they only intersect at one point. Let me zoom in for a bit. Okay, they intersect at one point, which means that this is the only solution. That's where they intersect. That's the only point that satisfies both of those lines. Okay, if I look at my no solutions, which we just did for your higher level thinking. Okay, if I have one linear line, let's say a horizontal slope, which is our zero slope, and we also have another zero slope that runs parallel with it, where again, when it extends out, these arrows means it extends, it will never ever touch. Do they ever intersect? No. So are there any solutions to this system of equations? Okay, no, there's not a solution because they don't intersect. So now our third type of solution is our infinite solutions, or many solutions. That's when, if I have this linear line, okay, I can have that same exact one that really just lays on top of it. It has the same exact points. They share the same exact points, same ordered pairs, everything. So, since they share all those points, we have lots of points where they intersect because they're laying on top of each other. So that's when we have infinite solutions, and infinite just means many. Because every point on those lines satisfy each other because they're the same exact thing. Okay, now I want to talk about investigating systems of equations. So first of all, I have to make sure that all of my equations are going to be linear. So I need to have a really good understanding of my slope-intercept form. And we've talked about it before, but slope-intercept form is y equals mx plus b. What does the m represent, and what does the b represent? Go ahead and take time to fill those out. Okay, you should have put, for the m is our slope, it's our rate of change, which is our rock, our constant, and our unit rate. The b is our y-intercept, and that's where the line crosses the y-axis. So whenever we plot it, okay, wherever it crosses the y-axis is going to be our b. So now if we look at this problem, it says graph the pair of equations working together. So for this first one, I'm going to use my green marker, and you can use different colors as well because that helps identify since we're going to be all in the same graph. Okay, I have the equation y is equal to 3x minus 2. Okay, I need to identify my b and my m so I'm able to graph the pair first. So in this equation, my b, which is my y-intercept, is what number? Should be negative 2. That's where it crosses over the y-axis. So right away I'm going to put a point at negative 2 in this color. From there, my slope, which is my m, okay, says it's 3. However, I need to put that as a ratio or a fraction so it's easier for me to graph. So I'm going to put it over 1 so it still holds its value. So with this, I know I'm going up 3 to the right 1. So from my y-intercept, I go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Okay, from there I'm able to draw my line. Okay, now since we're graphing a system of equations, I have to graph this other one as well. Okay, because the system, what they want me to graph is in this little symbol right here. So my second one is y is equal to negative 2x plus 3. I need to identify my m and my b to graph this appropriately. So my b, which is my y-intercept, is going to be positive 3. And I'm going to plot my point, 1, 2, 3. And from there, I notice that my slope is negative. So I know my graph, this equation should be going down from left to right. So my slope is -2, and I want to keep it as a fraction, so I'm going to put it over 1. So from my y-intercept, I'm going to go down 2, 1, 2, over 1. Down 2, over 1. Down 2, over 1. And connect those points and put arrows on the end to show that it is continuous. So those are my systems. That's my system of equations with my two linear equations. So now B wants us to explain how to tell whether 2, 1 is a solution to the equation y is equal to 3x minus 2. Now y is equal to 3x minus 2 was my green equation. And they're saying, how can I tell if 2, -1 is a solution? So that means, is it included on that line? So if I plot this point, 2, -1, over 2 on the x-axis, down 1. Okay, is that a solution to my equation that was y is equal to 3x minus 2? That was my green. No, it's definitely not. Okay, oh, and you know what? I just realized it says without using a graph. So, we could use the graph, however, they don't want us to use the graph, so we're going to do it a different way. How would I do this a different way? Well, if they give me my point, remember this represents my x and my y. So, couldn't I just plug it in to see if it's a true statement? Okay, let's try that. So in that space provided, put y is equal to 3x minus 2. I'm going to plug in 2 for the x value. Y is equal to 3 in parentheses 2 minus 2. And my y value is -1. So really, I'm not going to write down that y. I'm going to put -1 in place of it. So now if I solve, I'm going to multiply the 3 times 2 first. Okay, so I have -1 on the left side is equal to 3 times 2 is 6 minus 2. 6 minus 2 is what? 4. So they're saying with this solution, is it a solution to this equation? Is that a true statement? No, that's not a true statement. So this point cannot be a solution. It's not on that line. So it's not a solution. Let's look at C. Explain how to tell whether 2, 1, same point, is a solution to the equation y is equal to -2x plus 3. That was my blue line, without using the graph. So this time I'm going to read the directions all the way through because I know STAR fools me all the time with that. So I'm reading the directions all the way through and I'm not going to use the graph. So I know if this is a solution, supposedly, for this line, it has to fit into this equation and make a true statement with the same number on both sides. So, I'm going to take my equation, y is equal to -2x plus 3, and I'm going to substitute 2 in for x, -1 in for y. So when I rewrite the problem, it should be -1, which is my y value, is equal to -2 in parentheses, 2, which is my x value, and then plus 3. So now if I solve, I have -1 on the left side. -2 times 2 is -4 plus 3. And one more step, -4 plus 3 is going to be -1. Now, is that a true statement? Is -1 equal to -1? It sure is. So, with this being said, I know that this point is a solution to this equation because when I plug it in, it makes a true statement. Okay, so that was just saying, is this point a solution for this line? Is this point a solution for this line? The next E is going to say, find the point of intersection of the two lines. What is that also called? The point of intersection of the two lines. That's our solution to this system of equations. Okay, so at what point do they intersect? If you look, they intersect at this point right here. Remember, our solution is written as an ordered pair. So, I need to look for this ordered pair. So if I go over 1 on the x-axis, up 1, my point of intersection is 1, 1. Now, we have to check this solution by actually plugging it in to see if it makes a true statement. So again, for my green line, I'm going to plug in 1 for y is equal to 3 times 1 for x, and I'm going to solve. I'm going to draw an arrow down the middle of my equal sign to separate my sides. So I have 1 is equal to 3 times 1 is 3 minus 2 I'm going to still simplify. 1 is equal to 3 minus 2 is 1. Okay, so yes, that's a true statement. So I know that this is a solution for this equation. Okay, let's check the other equation in our system. Y is equal to negative 2x plus 3. If I do the same thing by plugging in these x and y values into my equation, it should make a true statement. So I'm plugging in 1 for y is equal to negative 2 times 1 for my x plus 3. Draw a line down the equal sign to separate your sides. 1 is equal to negative 2 times 1 is negative 2 plus 3. Okay, if I owe you $2 and I have 3, I'm going to still have $1. So I know that 1 is equal to 1, so yes, this point satisfies this solution as well. If this point satisfies both of these this equation, then I know that this point of intersection is a solution for both equations. It satisfies the system of equations here. Okay, now let's take another second just to look at solving the systems of equations by graphing. So remember that a solution is an ordered pair where the linear equations intersect. We already know that. So let's take a look now at number 3. Okay, it has the little symbol that shows that this is our system. There's 2 linear equations in this system. I already color coded them because that helps me see where each line is. So for this blue line, I need to graph this first. So off to the side, I rewrote the equation. My b is going to be positive 2 because that's my y-intercept. And I'm not sure what the m is because there's really not a number there. So what would my m be? What's my slope here? It's negative because I know it has a negative sign. But what number really is sitting in front of that x? Okay, some of you should have said 1. Our slope here is negative 1, and I'm going to keep it as a fraction, so I do my rise over run. So I'm going to plot my y-intercept, which is positive 2. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. And I'm going to connect those points with the line to show that it's continuous. Okay, my next equation in this system is going to be y is equal to negative 4x minus 1. My y-intercept here is negative 1, so I'm going to plot that point at negative 1. And my slope is negative 4, and I'm going to make it a fraction, so I do my rise over run a little bit easier, over 1. So negative 4 over 1. So from my y-intercept, I'm going to go down 4, 1, 2, 3, 4, over to the right 1. I'm going to plot another point, so I'm going to start at my y-intercept again, but I'm going to do opposite. So since I went down 4, I'm going to go up 4 now. 1, 2, 3, 4, and now I'm going to go to the left 1. Okay, I'm going to plot that point, and I'm going to connect my points to show it's continuous with arrows on the ends. Okay, and now I need to figure out what the solution is. So, it looks like the place of intersection for both of these equations is right here, which that ordered pair is negative 1, comma, 3. Now, I need to be able to check this to make sure that this is the solution for both equations, because if it only satisfies one equation, it's not going to be a solution for the system of equations. So, I'm going to take a look at my first one, which is y is equal to negative x plus 2. I'm going to plug in negative 1 for my x and 3 for my y. So 3 is my y. I have that negative sign already, so I need to substitute the x with another negative 1 plus 2. I'm going to separate my left and right side, so I have 3 on the left. Now I have 2 negatives next to each other. Whenever I have 2 negatives next to each other, that operation is really multiplying. So same signs, okay, or if my socks match, okay, I'm happy. So it ends up being a positive 1 plus 2. And I add 1 and 2 together, I have 3 is equal to 3. So I know that this point satisfies the blue line, because it's a true statement. Now I have to check the other line, my green line, which is y is equal to negative 4x minus 1. Okay, I'm substituting again 3 in for my y from this point. I'm going to substitute negative 1 in for the x and solve. So 3 is on the left side. Negative 4 times negative 1, my socks match, or my signs match, so it's going to be a positive answer because I'm happy because I have matching socks. and then minus 1, and I'm going to simplify. 4 minus 1 is 3. So again, it satisfies that problem as well, so I know that I did this correctly because this point is on this line, which is negative 4x minus 1, and my blue line, which is negative x plus 2. Go ahead and do number 4 by yourself and pause the video to check your answers at the end. Okay, looking at these equations, my first one is negative 2x plus 5. So my b, or my y-intercept, is plus 5. I'm going to plot that on my graph. And my m is my slope, so that's negative 2 over 1. So from my y-intercept, I'm going to go down 2 to the right 1. Down 2 to the right 1. And I'm going to draw my line to show that it's continuous. Okay, that's my first one. Now I have to plot my second line. Okay, so again, do I have a number that represents my b? This is in the form of y is equal to mx, but I don't have a b here. So since I don't have anything there, I know that my b, or my y-intercept, is 0, which means it's proportional. Okay, my slope here is positive 3, and I'm going to put it over 1 to make it easier for me for rise over run. So from the origin, I'm going to go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, and over 1. I'm going to connect my points and put arrows to show it's continuous and keeps going. And it looks to me like my point of intersection is right here, which would be the point 1, 3. So in parentheses, 1, comma 3. Okay, to check this, I'm going to use my equations and substitute our solution in the equations to see if it's a true statement. So y is equal to negative 2x plus 5. I'm going to plug in 1 for my x, 3 for my y. 3 for my y, and 1 for my x. And make sure we use parentheses when we substitute. So now I have 3 is equal to negative 2 times 1 is negative 2 plus 5. Negative 2 plus 5 is going to give me 3. So yes, that's true so far. Now we have to make sure that that point satisfies the other equation in our system too. So y is equal to 3x. Okay, I'm substituting in 3 for my y and 1 for my x. 3 stays on the left. 3 times 1 is 3. So this ordered pair satisfies this equation and this equation because when I plug it in, it makes it true. So I know that this is the solution to this system of equations. Okay, so going back to look at our essential question, how can you solve a system of equation by graphing? If you understood this aspect right here, okay, you will do perfectly fine and you should be able to answer our essential question. Just remember that the solution to a system of equations is the ordered pair, or where the linear equations intersect. Okay, I will see you tomorrow and have a great evening.